Okay, let's start off by going over the bell ringer. Maria had $22 to spend on 5 pencils. So she had $22 to spend on 5 pencils. After buying them, she had $12 left. Write an equation that could be solved to show how much each pencil cost. So here's how I break it down and think about it. If she started with $22 and she's got 12 left, how much money did she spend? Well, she spent $10. So where did our total come from? Our total came from the number of pencils times the cost of the pencils. So we know she got 5 pencils. We don't know how much each pencil cost. So that's our variable. Now we can simply solve this. Each pencil costs $2. Number 2, the sum of 3 consecutive numbers is 333. Write an equation that could be solved to show what the smallest of the numbers is. So we did this one in class yesterday. And so I want to show you a little bit about how we did it in class. We just picked 3 consecutive numbers. So we did 4, 5, and 6. Okay? I know these are not these numbers, because if I add 4, 5, and 6, I'm not going to get 333. But this just kind of gives us an idea to get started. If we start with the first number, how did I get from the first number to the second number? Well, if this is my x, this is the first thing I don't know. I can say x plus 1 and get to that number. Well, how can I get from the first number to the fourth number? Or to the third number? X plus 1, 2. So this is our general terms, right? We use these 3 to add up to this. So x plus 1 plus x plus 2, this plus this plus this equals 333. So I have 3x plus 3 equals 333. Subtract 3 from each side. 3x equals 330. Divide by 3. X equals 110. So my first number is 110. Right? Because that's what x is. That's the smallest number. What's this number? Right, 111. And this one would be 112. Okay, let's talk about today's lesson. We're going to talk about the birthday party task. Baskin-Robbins hosts birthday parties. To have the party at Baskin-Robbins, it costs a flat fee of $10. Flat fee. Well, that is my constant. Okay? That's my constant. Each party goer receives a single scoop of ice cream that costs $2. So this is my rate. $2 each. Write a function that can be used to determine the total cost y. So that y, total cost. We also know that to be f of x. Our total cost is equal to the number of cones, x, so what would we multiply times our number of cones? Well, that's our rate. Rate is rate of change or slope. So each one each cone costs $2. Okay, but that's not exactly what our total came from. What else did we have to add to the ice cream to get our total cost? If you look back up here, it has a flat fee of $10. That's our constant. So it doesn't matter how many people we have at this birthday party, they're going to charge $10. So plus the flat fee. So here is our function. Here's what each one means. So X is the number of cones. 2 is the rate for each cone. 10 is the constant, or the flat fee. And our f of x, or we call that also our y, is our total. We put this in slope-intercept form. X was our input or our domain. It's not part of the slope. Notice how when we look here, X was the number of cones. It wasn't part of our rate for each cone. X is not part of the slope. Our Y is our output. It's our total if cost is not given. M is our slope or rate of change. Y-intercept is the initial amount. You could also see it as a fixed amount, or it's where X is equal to 0. Okay? It is just that, okay, you start at this amount. So let's sketch a graph that models the problem situation. First off, our equation was f of x is equal to 2x plus 10. So where did we start? What's our y-intercept? 10, right? So we started right here. And then the cost of one cone, so this is our cone, number of cones. The cost of one cone is $2. That makes our total $12. The cost of 2 cones is $4, so that makes our total how much? $14. The cost of 3 makes it 16. The cost of 4 makes it 18. The cost of 5 makes it 20. What is our rate? Well, each one of these go up by 2 and over by 1. So you've got to always watch your graph. Notice each one of these moved by 1, but each one of these moved by 2. So I'm going up 2 and over 1, up 2, over 1, rise 2, run 1. That's our rate. That's what we get it from, up 2, over 1. Now, you notice I did not connect these. They're not connected. Why would they not be connected? Why are they not connected? Why are they not connected? Well, does it make sense to order half of an ice cream cone? You can order a smaller ice cream cone or have them not fill it up as much, but they're going to charge you for 2 cones. So if you ordered, I need a small cone with hardly any ice cream in it, they're going to charge you for the whole cone. So this is what our graph would look like. Okay. Baskin Robbins hosts birthday parties. To have the birthday party, it costs a flat fee of $10. Each party goer receives a single scoop of ice cream that costs $2 each. And we came up with the function f of x is equal to 2x plus 10. What is the domain? Domain is all of your x values. What did we talk about in this graph is for all of our x values? They were going to be whole numbers, right? Whole numbers. 1, 2, 3, 4, 5, 6, 7, 8. Now, what happens? A single is 5 scoops. Is $5 for 1 full scoop. A standard is $5 for 2 half scoops. Kids is $4 for 1 half scoop. A trio is $6 for 3 half scoops, and half scoops are $1 each. So what is available would depend on your domain. We're doing just the base problem. So here it's all whole numbers. So it doesn't include negatives, and it doesn't include decimals. No negatives and no decimals. So I have a quick little chart that's going to help you. Does it include negatives? Does it include decimals? Then it's real numbers. Does it include negatives and not include decimals? Then it's integers. So real numbers are all numbers as long as they don't go on forever, like have a never-ending decimal. Integers is your numbers, like -2, it includes all your negative numbers as well as your whole numbers. Positive numbers are just 1, 1.2, 3, etc. It's going to include decimals. Your whole numbers, think of those as counting numbers. How do you count? 0, 1, 2, 3. So there's no negatives and no decimals. Linear function word problems. We'll come right back to this. I'm going to end this video. Make sure you stay tuned for part 2.